Hello, welcome to my channel class 11. Today is your turn. We will discuss the limitations of dimension analysis today and then error analysis, accuracy and precision and types of errors and their computation. Let us discuss with the limitations. Before that, I would like to say please subscribe my channel and also press the bell icon for further notifications. You know that dimension analysis, you have seen there are three applications of dimension analysis. Then what are the limitations? You have seen that there is an equation for kinetic energy. Then suppose kinetic energy is given by k equal to half mv square. Then this half, we cannot derive a relation in which if it is given that kinetic energy of an object depends on mass and velocity, then derive the dimension with the help of dimension analysis. You derive this equation, but you can't get the value of half. So what is the limitation? We can say that this dimensional analysis cannot give the value of the dimensional constants. We can derive the equations which are dimensionally correct. We cannot find the value of the constants occurring in the relation. For example, in the time period of pendulum t equal to 2 pi under root L by g, we cannot get the value of, we cannot derive exact t equal to 2 pi under root L by g. We can derive t equal to some constant into under root L by g. Now, the second limitation is that this method cannot distinguish between the quantities which are different but having same dimensions. So, you can say that this method does not distinguish between the physical quantities having same dimensions like pressure, force upon area. So, what will you get? The dimensions of pressure, force upon area. So force is mlt minus 2 upon area L2. What will you get? ml minus 1 t minus 2. You know, if this is the dimensions of pressure, and you know, if you take another example, for example, this is the any force, only this dimension, force, pressure, force upon area, and you can also write the stress. So name is different. One is stress. Stress is also reactionary force per unit area, but if it is written ml minus 1 t minus 2, whether it is pressure or it is stress. Similarly, Young's modulus y, it is also stress upon strain. So strain is dimensionless. So Young's modulus or coefficient of modulus of elasticity, stress, pressure, they are different quantities but their dimensions are same. Third, if any of the equation has trigonometrical ratio, logarithm ratio, exponential ratio, then we cannot derive that relation. That is, in any of the relation in which these terms occurs, logarithmic, exponential, trigonometrical ratio, then they cannot be derived with the help of dimensional analysis. Also, the next one, that is only dimensions validity, not the exact relationship, is checked by this dimension analysis. It fails to derive another one limitation. It fails to derive the relationship between more than 3 physical quantities. If a quantity depends here, like kinetic energy depends on mass and velocity. If in any other relation some quantity depends on the 3 quantities, it can be derived. But if a quantity depends more than 3 quantities, then we cannot derive a relation using dimensional analysis. So in this way, we can say that what are the limitations of dimension analysis. And finally, if an equation fails the consistency test, it is proved wrong. But if it passes, it is not proved right. What is the meaning of this? That is, a dimensionally correct equation need not be actually as the exact equation. Exact equation is, for example, t equal to 2 pi under root L by g. But if you have derived t equal to some constant under root L by g, then it is not exact, but it is dimensionally correct. And if any of the equation which is dimensionally incorrect, then totally it is wrong. It is neither exact nor it is correct, dimensionally correct. So these are some limitations of dimensional analysis. Now after that, another term is there, accuracy and precision. You know, any of the measurement, when it is measured, then accuracy means, suppose there is a true value. If you take interest with the help of example only, then you will able to learn the meaning of accuracy and precision, then you will be able to define. Look, suppose the true value of any of the measurement, suppose of the length is suppose 4.678 meter. This is true value. Now look, what is accuracy? Accuracy means how close is the measurement to the true value. Closeness of a measurement, its result to the true value. Suppose in one experiment, this value is measured as 4.5 meter, and in other experiment it is measured as 4.36 meter. Actual value is, true value is 4.678. In one experiment it is measured to 4.5 meter, and in other experiment it is measured 4.36 meter. Listen, what is accuracy? First you decide which is closer to the true value. This is 4.5 and this is 4.6. This difference is less. So this value is more closer to the true value. Yes, and it is less closer. Its difference is more. Now what is precision? Precision means up to which limit you are measuring. What is the resolution? Here up to the 2 places of decimal you have measured, but the difference of true value and this is more. So precision, how it is defined? How close, how in up to which limit of resolution this value is measured, or what is the resolution in the decimal place. The resolution means how many decimal places. So look here that this result, how will you write? It is more accurate. How more accurate? Because more closer to the true value, but less precise. Less precise means it has only one decimal place. How will you write here? More precise. Why more precise? Because it has limit of resolution up to 2 places of decimal it has been measured. And less accurate. Why? Because difference of this and this is more, so it is less accurate. So in this way the measurement is said to be how it is precise, how much accurate. Now come to the error in a measurement and types of errors. You know this here. What are errors? Suppose you measure certain quantities, then these errors in a measurement are, that is, if you measure some quantity, then errors are difference between true value and measured value. So if you want to measure error, then this is true value minus measured value. Now types of errors, I have made this table that how many types of errors you know. Types of errors are here: constant error, random error, least count error, gross error, systematic errors. And in systematic errors, again instrumental imperfections in experimental techniques, personal errors, and errors due to external causes. How? Look, constant errors, that is if the calibration is not correct, then every time in every measurement there will be the constant error. Similarly, random errors, it occurs randomly. Least count errors due to the least count. So these types of errors, you can go through the each and every heading and you can find what are these errors are. How will you eliminate errors? Such type of errors are there. Suppose personal errors. In some experiments, we have to listen the sound which is maximum. Sometimes you listen this one, and then again you perform the experiment. Then you listen, then you seems that this is the max more than first one. So it depends on person to person, varies person to person. So this type of personal error. Similarly, all these errors, how you eliminate errors, that is, you take the length, you measure in the class 11, you will measure the length and diameter of a cylinder using vernier calipers. So it is written in the books and practicals that take 5 measurements. Same cylinder. Why 5 measurement of length and 5 measurement of diameter? More and more observations, then you take mean, then you are minimizing the error. So errors can be minimized by taking more and more number of observations and their mean. Look, for example, absolute error. Suppose there are certain measurements A1, A2, A3 and AN. Single length measurement, suppose length of this pencil, then you have taken n times the measurement. What is absolute error? Sometimes you find error equal to the least count of the measuring device, and that may be less or more than the measurement taken. So what you do here, that first you take all the measurements, and if you find their mean, so what will you find? How will you find their mean? By taking these sum of all the observations and divided by n. Then how can you write? This will be a mean, or this is denoted by this. How will you find the difference? This A1, you know, it is written as delta A1. How will you find this minus A1? Similarly, delta A2, that is second measurement. What is the difference? You will find a mean minus A2. So in this way, you can find that all these delta A1, delta A2 are the differences of this measurement you have taken initially, then how much it is, how does it vary from the mean of the all measurements. So in this way you will find delta A1, delta A2. Now what will you do? That if you take the measurements in this way, and then what do you do? That mean or final absolute error, that is, you will find delta A, this, by having this one, this 2, this delta A1, this delta A2, taking only the magnitude. Some may be negative, some may be positive, but you will have to take only the magnitudes, and all these you will have to add n upon n. So in this way you will find mean absolute error. What is relative error? Relative error is suppose denoted by A. How will you find relative error? Relative error is, suppose this is delta A upon A. This one is relative error. How will you find percentage error? Percentage error is, you find here this. By solving so many examples, you will come to know how these errors are counted and calculated. I will give you simple examples, then you will come to know that how it. Suppose how the errors are computed. So we will first give the rule in computation of error, computation of errors in sum or difference. Look, suppose there is a quantity A, it is measured by certain device, then its value is A plus minus delta A. You know what is delta A? Suppose you measure this length by scale, then that length is suppose 1.6 meter. You can measure only up to the one place of decimal by the scale, and here you say that this 1.62 or 1.61 meter maybe. So this is the least count error, or this error may be there, plus minus it is written. Similarly, another quantity B, it is measured, then it is written as B plus minus delta B. This is the error. And absolute error is always positive, you should know it. Now in the sum or difference, the same rule occurs. Suppose we take the example of sum, how to compute the error in the sum of these two measured quantities. Its sum is Z, then you write Z equal to A plus B. Along with errors, how will you write? Z plus minus delta Z equal to A plus minus delta A plus B plus minus delta B. Will you write or not in this way? Now you can write here this A plus B, rearranging, plus minus delta A plus minus delta B. If the sum is Z equal to A plus B, then this is Z and this is A plus B. This will be eliminated. Z is same as A plus B. What is left here? This is delta Z equal to plus minus delta A plus minus delta B. Listen again, that absolute error is always positive. So what will be the error in the sum of these two quantities? It will be written only as plus delta B. Similarly, in the difference also, you have to do yourself, like Z equal to A minus B. Then how will you write? A plus minus delta A minus B plus minus delta B. You can write here. Then you will write A minus B. And here, if you are writing, then you will write Z plus minus delta Z. Then here again Z plus minus delta Z you will write here. This is A minus B. Then this is plus minus delta A, and plus minus plus you can write or anything delta B. Then again this Z and A minus B will be cancelled, and what is left here? Delta Z equal to, you will not take the minus sign because errors are always added. So you will write only delta A plus delta B. So whether the delta A plus, this is the sum you have proved here for this Z equal to A plus B, this equation, same is for Z equal to A minus B. Similarly, the computation in case of product and quotient, how will you? Suppose there is the same quantity A and B we will take, then how will you write in the product? So the rule for product and quotient are same as for rule in sum and difference. Product case, suppose Z equal to A into B. Again the measured quantity is A plus minus delta A into B plus minus delta B. What will you write here? This is Z plus minus delta Z. Now open the bracket, this will be AB, A into B plus minus A into delta B plus minus delta A into B. You should know how to open the bracket. and this is plus minus delta A into plus minus delta B you have written. You know what is the meaning of delta? A slight change, a little error, and delta is very less in the decimals, and product of two delta means product of two decimal values which will become less. If one delta is only 0.1, then 0.1 into 0.1 will become 0.01. So this will be very small. It can be neglected. What is left here? This is z plus minus delta z. Again z is AB, so this z and AB is cancelled. What is left here? This is delta z. And what is here? This is, you divide, this is AB plus minus, you write here like this, A delta B plus minus delta A B. Now in the LHS you divide with this equation, then LHS divide by Z, in RHS divide by AB. What will you get here? Z by Z, you divide here by Z and here by AB. Then what is? This is 1 plus minus delta Z upon Z equal to, what will be here? 1 plus minus, what is left here? Delta B upon B, because A and A will be cancelled, plus minus delta A upon A. Here B will be cancelled. This now 1 is cancelled. What is left here? This is delta Z upon Z equal to delta A upon A. Write the first term before, and plus delta B upon B. Again the minus term is not written because absolute errors are always, they are added. The same result you will get if there is Z equal to A upon B. Then also you will get the same result. So in this way, the computation of this errors or in product quotient or sum or difference, you will get the result. How this result is applied? When there is a power, suppose Z is given A to the power n, then you know what will be the error in Z? This delta Z upon Z, suppose it is written, then it will be n into delta A upon A. You know delta Z upon Z is relative error. If it is written in terms of percentage error, this is percentage error. Look the rule. It is given in a question that there is a sphere and the error in its radius, error in radius of a sphere is 2%. Find the error in its area. Which error? Percentage error, percent it is given. How will you find? You know, it is given the first line and you have to write in a mathematical way, read the question, then how will you note down? You will note down that it is given delta R upon R equal to 2%. This is the percentage error. Then what is area of the sphere? Area is 4 pi R square. So R square. How will you write delta A upon A? This will be delta A upon A will be 4 pi is a constant. You pay attention here, because students normally I have seen they multiply 4, then put the value of pi, then no. You are calculating the error in the where it is permissible. 4 pi is constant, then what error may be in 4 and pi? No. The error will be like this. You will suppose that A to the power n, here R to the power 2. Then what will you write here? It will be written as 2 into delta R by R. This is the case, and so many examples are there. You have to solve. Now what will you find here? That delta A upon A percent. What's percent error? It is given 2 into this is given What percentage error is given? 2. So this is 2%. So what will be the error? 4%. So many example. There is a thermometer which reads 20 degrees Celsius plus minus 0.2 degrees Celsius, and another thermometer reads 30 degrees Celsius plus minus 0.2 degrees Celsius. Find the difference in the temperature. Now look, it is asked find the difference. Most of you know difference is delta 2 is 2 minus T1. Most of the students write is 30 minus 20, 10 degrees Celsius, because 0.2 minus 0.2 is 0. This is wrong. What I am telling, that this error is always added. In first measurement error is this, second measurement error is this, then what will be the net error in the difference? And you have seen in the difference what was the result? Error was delta A plus delta B. Here it was plus. Here it is T2 minus T1. But in case of error, what will you write here? This is plus, and what will you write? 0.4 degree Celsius. So in this way you have to learn. So many examples are given, because if I am giving the example, so how will I continue further? There are so many things which I have to tell. One more example, V equal to IR. If V is given, suppose V is given 100 plus minus 4 volt. And I is given 10 plus minus 0.2 ampere. Find the percentage error in R. Now, if most of the students, what do you do the mistake here? R is written as R is V upon I. Then error in the quotient. What will you find percentage error in R? Delta R upon R percent. What will be? First you write the relation. It will be delta V upon V percent plus delta I upon I percent. Look, it is upon, but you have to write here plus. What percent of V in 100? 4 is the difference. This is V plus minus delta V. So difference is 4 volt in 100. So this is directly in 4%. So you can write here 4%. Now look here, in 10 ampere difference is of 0.2. So in 10, if the difference is of 0.2 ampere, then what will be percentage? Then in 100 it will be 2%. So this is plus 2%. What will be the answer? 6%. So if error in voltage and current is given, how to find error in resistance? I have given so many examples. I hope you must have understood this. Now after that, what is the rule for rounding off? Rounding off rules in a measurement. Suppose they are very easy. You must have, I think most of the students will be knowing it. Suppose it is given that there is a quantity 2.467. Round off up to 2 places of decimal. Then this is last place is 7. Then what will you do? 7 is seen, last place is observed, that if it is more than 5, then in the second last place preceding digit add 1. So what will be here? 2.47. If it is written 2.465, or suppose it is written 2.462, then if this is seen less than 5, then it will be 2.46. Now again, if it is 2.465, what is seen that if the digit which is to be eliminated is 5, then preceding digit is observed. If it is even, then it is written as it is, no change. This is 2.46. And if it is odd, if it is 2.475, then what will you write here? This is 2.48, because if it is odd, then 1 is added. If it is even, then 1 is not added. So in this way, when 5 is to be eliminated, more than 5, less than 5, it is clear. If 5 is to be eliminated, then it is observed that what is one digit before, that is 6. So what will you do? You leave as it is up to 2 places of decimal. And if you have to write this value up to 2 places of decimal and last digit is 5, but before that odd number, that is 7, then you have to add 1 here, then it is 2.48. So in this way, rounding off is done. Now I hope you must have understood these. In the next video, I will discuss the significant figures and all the operations in sum and difference, product and quotient regarding significant figures. Thank you.